All right, so having a look at this warm-up. Uh, it says to write the exponential function to model each table, label each function as growth or decay. So what I notice is that my x values here are adding 1, and that's helpful. It makes it a lot easier to see the change here. Here we're multiplying by 5. So we're multiplying by 5, or excuse me, dividing by 5, which is the same as multiplying by 1/5. So multiplying by 1/5 is the same as dividing by 5. And so we're going to think of it that way. So our equation then, we can see our y-intercept right there. So we have y, or d of x, excuse me, there I see the d of x. D of x is equal to the 100 times the 1/5 to the x power. And that's our equation. We can see that because when we put 0 in here for x, 1/5 to the 0, well, surprisingly, anything to the 0 power is 1. So this all becomes 1. 100 times 1 is 100. And then this 1/5, that's the change here, like that. All right. So in the next one, we have g of x. And here is our y-intercept there of 1/2. So we have g of x is equal to the 1/2. And then what we're changing by here, it might be easier there to see in the second part. 4 times what equals 32? Well, another way to think of that is 32 divided by 4 gives me 8. Well, really here it's 8. And then is it also true that 4 divided by 1/2 is 8? Yes, that is true. So that tells me that my b value here is 8, and it's raised to the x power. Questions on that warm-up? Good morning, Elizabeth. Good morning, Rylan. Elizabeth, good to have you here with us. Welcome. Any questions about that warm-up? All right. So these are a little bit harder, maybe. I think they are. Um, we're going to try to do the same thing here. So just quickly think about f of x. Can anyone tell me, what does this part right here tell me? That's the y-intercept, yep. And what does it tell me as far as the function goes when I'm writing the equation? Do you know, Shady? Yeah, great, thank you. So we have the 1/3. And now, how do we figure out our multiplier? How are we going to figure out that? Because look at those fractions. Those are nasty, right? I know you guys don't really love fractions. How do we figure that out? Well, a couple ways we can do it. We can think about 1/3 times some fraction is equal to 2/9. Well, 1 times what is 2? Well, 1 times 2. Here, I'm going to do it in red. 1 times 2 is 2. And 3 times what is 9? Well, 3 times 3 is 9. So here we're multiplying by 2/3. Well, let's see if that's true here as well. Well, is 2 times the 2? Let's see, let me do that again. 2 times 2, is that 4? Yes. 9 times 3, is that 27? Yes. So that same pattern of multiply by 2/3 is maintained. So here we have 2/3 to the x power. There is another way to see this, and it's honestly a little harder, I think. We can take this 4/27 and divide by 2/9. 4/27 divided by 2/9. Does anyone remember how to divide fractions? How do we divide fractions? Well, the first fraction stays the same. Instead of, we change that division to multiplication. And when we do that, change that division to multiplication, we have to take the second fraction and flip it upside down. It's called the reciprocal. So 9/2. And now we can multiply. 4 times 9 is 36. 27 times 2 is 54. And you maybe are saying, wait, but it was supposed to be 2/3. Yeah, 36 is divisible by 18. 54 is divisible by 18. So when we divide by 18 in the numerator and the denominator, we get 2/3. Personally, I find this more difficult than setting it up the way I did before, where I said, okay, well, in the numerator, what do I have to multiply? And in the denominator, what do I have to multiply? But you can decide for yourself. Maybe sometimes one way is easier, sometimes another way is easier. That's also possible. Good morning, David. So glad you're here with us. All right, so here we have h of x. Is anyone willing to be brave and tell me how to write the equation here? Nobody's brave this morning. You can't be brave if you're not a little afraid. So if you're a little afraid, the situation is just right for some bravery. It's just the act. Yeah. Great job, Elizabeth. Elizabeth, thank you so much for volunteering. How I see that you got this 1/3. It looks like right here, and you're so super close. But there's just one problem, Elizabeth. It was a little bit of a trick. I'm sorry that on the first time you talked in my class, it was on a trick. This is not the y-intercept. So that's going to be a little bit misleading. The 6 is absolutely correct. You can see that multiplying by 6 here gives me the 12. And multiplying by 6 there is also that same 1/3 times 6 is 2. But how do we fix this to get the right number there? Yeah, so good. That's so good. That's a great recovery. Thank you, Elizabeth. So we take that 1/3 and we divide by 6, which is the same as 6/1. Well, again, when we're multiplying fractions, we take that 1/3 and we multiply by the reciprocal of 6, which is 1/6. So we get 1/18. So our actual value there at A is 1/18. Questions on that? Okay, I'm going to pause the recording. All right, appreciation and depreciation review. Appreciation and depreciation are when a quantity changes by a percent rate over time. You can model these with exponential functions, y equals a times b to the x. However, it's sometimes easier, instead of using the b here, we have 1 plus or minus a percent, where the percent is the rate of appreciation or depreciation. And so it's important that we have the addition when it's appreciation, and we have the subtraction when it's depreciation. So we always know by looking at the sign whether it's appreciation or depreciation. And this one is always the same. All right, so it's always a 1 here inside the parentheses, plus or minus, depending on whether it's appreciation or depreciation, and then the percent of increase or decrease. So appreciation is increase, depreciation is decrease. As an example, let's suppose that we're investing $10,000 that grows at a rate of 5.25%. And we can model this with this 1.0525. Now I want to break that down so that we see a little better that it's 1 plus something, and it's 0.0525. And hopefully you remember that when we have a percent, to convert it to a decimal, we move the decimal to the left 2 places and put the new decimal there and add however many zeros we need to. So that's how we get the 0.0525 right there. Are there any questions on that? Okay, I'm going to give you guys about 2 minutes to look at that first situation and write an equation there. If you're watching this video at home, pause the video. Now that you've had a chance to try to write the equation yourself and figure out the answer here, the initial investment of $2,500 at a growth rate of 8.25% annually. So here we have y is equal to, that 2,500 then is our a value, and we have 1, because it's a growth rate. I'm gonna grows, so I'm gonna make that a plus, and then 0.0825 to the x power. So it's going to be y is equal to 2,500, and I can change this to 1.0825 if I want to, and that's just fine. To the first power will give me year 1, so I could highlight this whole thing or this as a year 1, and the result then, I'm going to pull up a calculator here to do this on. So it's going to be a 2,500 times 1.0825 to the first power, and I'll get $2,706, $2,706.25. Sorry about that, that got in the way. And the great thing about these calculators is that I can easily change my power there to 10. All right. And that will allow me to solve for this. So I just go up, hit enter, it'll copy it and paste it. Just put in a 0, that's to the 10th power. And so it's going to be about $5,523.56. All right. Are there any questions on those two? All right. Give the next one a shot for 2 minutes. And if you're watching this at home, pause your recording right now. All right, on this next one, we have a situation of depreciation with an initial value of the car at $10,000. Depreciation tells us that inside the parentheses, we're going to have subtraction, 1 minus. And then the percent is 0.145. So that's 14.5% to the x. Is that big enough for everyone to see, or is that too small? I started writing pretty small there. No complaints? Good enough. So we're going to do 1 year. So y is equal to 10,000 times, and this is going to be 0.855. So that's between 0 and 1. So that tells me that it is a depreciation, which is good because that's what we needed to have here. And our exponent is 1. So bringing the calculator back, we have 10,000 times 0.855 to the first power. And it's going to be $8,550 after 1 year. And that makes sense. We can see that 0.855 right there out of the 10,000. On the next one, we have y is equal to the 10,000 times 0.855 to the 10th power. Right there. And so that's going to equal, we'll go up here, copy and paste it, change it to 10, and we get, and this is sad. If you buy a $10,000 car, 10 years later, it's going to be worth about $2,087.66 or 67 cents, excuse me, because we're rounding to this hundredth, and this is great 5 or greater, so we have to round up. All right. Questions on any of that work? You can see that in all exponential functions, there's this flattening out. Here it flattens out that direction. Here it flattens out that direction. It doesn't ever go straight up here or here. And literally, it doesn't flatten out completely, but it gets closer and closer to flat the farther out you go. The horizontal line there is called the asymptote. I love this word. I don't know why, I just think it's a great word. The asymptote right here is x equals 0. It's also x equals 0 there. And so what happens is that if you could zoom in far enough here, so I'm going to draw in the asymptote. That's pretty terrible. Let me see if I can do a little bit better job. All right. If you could zoom in far enough, you'd see that it was always a little bit away from that line. And we can't zoom in that far on this program. But on the Desmos, we can a little better. So have a look. So it looks like it's at 15 here, x equals 15. It looks like it's really, really close, but we can zoom in and then it's farther away. And then we can zoom in and we can make it farther away. And if the further out we go, eventually, see, it gets closer and closer and closer. And if I keep going out here, it'll get just close the same way that it did before. Eventually, it would look like it was touching it. And then we could zoom out, zoom in further, and it wouldn't look like it was touching it anymore. So that's an amazing thing about these graphs, is that they have these asymptotes. The other key feature is the y-intercept here, the y-intercept, and then the growth factor or decay. So those are the key parts to these exponential functions: the asymptote, the y-intercept, and the growth factor or decay factor. So you're going to do a Desmos now. If you're at home, you can do the Desmos from home too. We're going to look at transformations of exponential equations. All right. So if you think about transformations like on parabolas, or we can move them. We can move them horizontally, so we can move them to the right or the left. We can move them vertically, up or down. We could take it and we could stretch it vertically, or we could flatten it out vertically. So we can also reflect it. So we could take it and we could reflect it across the x-axis. And it's the same kind of thing for exponential equations. The a value is a vertical dilation, so it stretches it. And it's also a vertical reflection. And the k value is a vertical shift. All right, so it's a vertical shift. So I'm going to give you another link to a Desmos. We are not going to have enough time to get through this Desmos during this class. I really, really want you to do this. If you don't have time to finish it up later. It's going to be really helpful. And then also, if you do one last thing for me, so you have the rest of the period to work on these two things. There's a Google form. It's an exit ticket. If you could do both of those for me today, I'd greatly appreciate it. The first one is a Desmos, and it's going to be a card sort, and so it's a total of 4 pages. So do the best that you can on that. You can take the rest of the period And I will see you next class on Wednesday. On Wednesday, there will be a video. I'll send that link out to everybody. And um, on a Thursday, there will be some more activities for you to do, and I'll send that information out as well. Have a great week, you guys. Work through those Desmos and the exit ticket, please.